Hello. All right. Good morning, everybody. It's nice to see a good number of attendees in the first morning session. All right. You can see that the title here is a bit different. I can fit all the words in here, but we are going to talk about the grid infrastructure overall in EU countries, as well as some specifics about the transformers. So basically, every piece of equipment going into the grid, specifically in the transmission sector and in the transformer side, since it's power transformers. So we'll talk about the market developments of power transformers. That what are the main causes of any increase or decrease in the market growth? What are the key factors which are impacting the market from the grid perspective and specifically from the transformers perspective as well. The overall agenda of the presentation is to sort of go through the grid planning in EU28, then specifically go into the components, interconnection between the EU countries, what's the role of HVDC, high voltage DC in that regard. That directly does not tie in with the content of this conference overall, but still, since we are talking about the grid overall, so we have to discuss these factors as well. And then we'll go into the specifics of the power transformers. We have EU28, and then for comparison, we have North American market as well to see that are the factors which are impacting the market same in North America, or are they different, to sort of make a comparison between the two different markets. And then at the end, we'll kind of take a step back from the regional approach, and then we'll look at the global overview from the supply and demand perspective. And the reason why we do that, we will also go into details that why do we have to kind of go back at the global level to sort of understand the supply and demand for the power transformers. Before starting the presentation, a bit of an introduction in terms of what we do. Basically, PTR is a market intelligence company. Mainly, we provide our content within grid infrastructure as well as industrial automation. The kind of work we do in all these sectors is sort of market forecasting, that what is expected to happen in, let's say, in next 5 to 10 years from grids perspective, as well as in industrial sector. And then from the OEM's perspective, who is doing what, who is focusing in which region, so kind of comparative analysis as well. And then at the end, sort of market accessibility, what are the business practices being followed in different regions, and kind of combine all this together into one package to our customers. Today, what you'll be seeing mainly will be market forecast, market sizing, not only overall grid infrastructure, but also the power transformers as well. Yeah, first of all, a grid planning overview. First, I wanted to give you an overview that if we just look at the EU countries, where do we see the maximum amount of investment going in? Where are the plans being initiated by the transmission system operators and the distribution system operators? This has been the case in the last 5 years, I would say, that the Western European countries, they're revamping their grid. Definitely, you see Germany over here. The reason why we'll go into details in a while, that what kind of projects are being announced, are these in HVDC or transformers, and why is it the case that they have to kind of revamp the grid infrastructure in Germany and some of the Western European countries. So this is the overall kind of the heat map that we get if we put all the data into the map, and that's kind of the overall overview that we get for the transmission infrastructure specifically. Okay, if we look at the timeline till 2030, there are different aspects that we can look into. First of all, transmission grid can also be segregated into multiple parts, because from OEM's perspective, not all the manufacturers can satisfy the needs of utilities throughout all these voltage and capacity ranges. Everybody has their own capabilities and restrictions in terms of what they can do. So they also need to look into which sector within the transmission is being revamped, where the investment is going on. So one key factor that you can see over here is kind of the extra high voltage sector is where a lot of investment is going on. So this is the key takeaway from this slide, that not the kind of the distribution and transmission handover grid, that is basically the in-between grid, where distribution operators hand over the grid towards the transmission operators. That's the 110 kV. In some countries, it's 130 kV. This is not the infrastructure or the network where the investment is going on. The extra high voltage, that's 380 kV or 400 kV, depending on the country where you are. This is where investment is happening right now. And that is taking into account every project. We will go into the details that which projects I'm talking about, but only in transmission sector. If we split up the technologies, AC versus DC, we'll also go into the details of DC as well in the later slides. But this is kind of the overall distribution between the AC and DC technology and the projects in both the technologies. If we only look at the equipment, what is going on within grid, so substations versus transmission medium, this is the one segregation that you can do. Within substation, you can have multiple pieces of equipment going in, but this is how the investment is right now. So you can see transmission medium, that includes overhead lines, cables, submarine cables, as well as underground cables. So a lot of investment is going towards the transmission medium. Why is this happening? We'll talk about it a bit later. And you can see the segregation between overhead lines and cables as well. Mainly the overhead lines, they're being either revamped, or in some cases, some networks, they're moving from one voltage to the other voltage entirely. That is the reason. In some countries, there is reconductoring in those networks. And in some cases, there are completely new lines being built because there are new substations in the area, or there are new generation capacities being added, so you need to have more transmission capacity as well. So that is another reason that you need to have more overhead lines in your system. If we map in terms of timeline, the number of projects in all the EU countries, this is the kind of output that you get. It is fluctuating a bit. It is because of the nature of this market. The projects are there planned way ahead of time, and some projects they get through, and some projects are being put on hold as well. So that is the nature of this transmission market. So it is fluctuating, but since there is a lot of long lead times involved in this sort of market, so that is why we expect this to happen. To go into the details, why do we see this kind of behavior in terms of the market growth? We can see what is happening with the transmission medium projects, that is transmission lines as well as cables. We see kind of similar trend, but if we look at the substation, this trend is even more visible over here in terms of substations. That includes new substations being added into the system. And as we saw, that 400 kV was the kind of category, the extra high voltage was the category where a lot of new substations were being built into the system. Now let's talk about some of the components. So we talked about the overall grid scenario. We saw overhead lines, we saw cables as well. It could be the case that it is for AC purposes, for overhead line. It could be the submarine cables for the DC interconnections as well. This has been happening in the past as well, that EU grid is kind of, it is being connected. Different countries are connecting their grid with each other for kind of two-way flow of the power because of the new renewables being installed into the system. So you need to have that capability, and HVDC is a perfect solution to do that, to have that capability, that flexibility into your system, so that you can have two-way flow of the power in and out of your system. This is the same graph that we saw earlier, that some investment is going towards DC side, and that mainly includes HVDC. It includes the lines as well as the converter stations as well for the DC purpose. If we look at the HVDC projects overall, that includes all the European countries on the left side. But on the right side, we have some of the countries where we have more number of interconnections being planned. You can see definitely this is one of the reasons why we saw that Germany was kind of the focus when we saw the first slide, where the overview of the substation investment was, or the grid investment was presented. So that was one of the reasons. And you can see that Germany, UK, they have these high voltage DC connections planned. It not only includes HVDC projects within the country, but also connections with the neighboring countries as well. One of the major reasons to have these interconnections is renewables are being installed within the system, and usually this is the case that the renewables are kind of away from the load centers, and you have to connect these generation centers with the load centers, and the distances are long. So HVDC, as we discussed, that it is kind of a perfect solution for this scenario. If we look at the capacities, we saw the number of projects previously, but in terms of capacities, these two kind of outliers, it is because, once again, nature of these projects, there can be some multiple gigawatts projects. For example, in case of 2022, there are, I guess, four 2 gigawatt projects being planned. So that is why it becomes kind of an outlier in terms of data. But yeah, you can see there's continuous new addition of capacities for the HVDC projects throughout. Now, if we look at the technology, the reason why I wanted to share this, that what is happening within HVDC, is because there is a trend in terms of the technology being followed in these HVDC projects. There are kind of two competing technologies that have existed for more than, I would say, 4 decades in this field. There's one old technology called thyristor-based line commutated converters, LCCs, and VSCs. I don't want to go into the details of the technology, but the reason why I already shared that, there is a trend that in certain regions, the tendency of OEMs is to go for one particular technology. The voltage categories that you see over here are mainly between 200 and 500 kV. That is still kind of the medium range, because in HVDC, the highest voltage that has been achieved, it is 1100 kV. And utilities and system operators are still planning to go even higher than that. But that is happening in countries like China and India, because over there, the main reason for these projects is to sort of transfer the power from the generation centers towards the load centers over extremely long distances, more than 2,000 kilometers as well. When that's the case, you need to have a higher voltage. And the old technology, thyristor-based technology, is the only good enough technology to sort of withstand those voltages. However, the newer technologies, which is more flexible, utilities do prefer that, because the footprint overall of the station gets really reduced with this new technology. So that can withstand only these voltage ranges. So since the projects are planned within these voltage ranges, even though the technology has not been announced by the utilities up until now, that tells us that still in the European region, the focus of the technology is going to be the IGBT-based, the newer technology that is more flexible, that also goes in alignment with the grid codes as well. Because since we discussed that it's more flexible, it has a smaller footprint, so the grid codes are becoming stricter in the recent past from the utilities. So that goes in alignment with this technology, because that kind of satisfies all those requirements being set by the utilities. Having said that, this is the overview, global overview, if we look at the HVDC scenario. And that is the prime reason, as we saw, that this new technology, VSC, is very prominent in the European region. And if you look at Asia, over there, we have a number of projects which are still based on the LCC-based technology, which is the older technology. But since it can withstand those higher capacities and higher voltages, and that is the need right now in those regions. Because the primary factor that is causing the market to go up is because of very huge hydro projects where you have multiple gigawatts to be transferred from the generation centers towards the load centers, and you have very long distances. In sort of European region, the HVDC, the average distance lies between 200 to 300 kilometers. But in those projects where you have even up to 10 gigawatts of connections, more than 2,000 kilometers, you need to have this LCC-based technology. And that is the focus of the OEMs as well. When you talk with some of the tier 1 players, you see the focus as well. Even some of the European players, they're really focusing on the LCC-based technology, because they still see a growth happening in the future in the Asian countries. A lot of projects being planned. I don't want to go into details, because we are not discussing those regions, but I just wanted to give you a comparison between what is the focus right now in European region for the OEMs, because of the plans from the utilities. Even though, as we saw in the previous graph, these projects, the technology for most of these projects is not being announced, but the nature of these projects suggests that they're going to stick with this technology in the future as well. Now let's talk about the other component, which kind of relates with the content of this conference as well, the power transformers. Originally, I just wanted to discuss the European market, but since we can also look at the North American market to sort of draw some comparison in terms of the key market drivers for the markets. And then also wanted to discuss one country-level market overview as well for Germany, because we saw that this is one of the strongest markets, so I wanted to discuss that as well. First of all, why are we kind of discussing the power transformers specifically? There's a reason for that. And as I said in the beginning, that for the supply and demand perspective, we'll basically go back towards the global scale rather than going into the regional level. It is because of the nature of this piece of equipment. It is a globally traded product, so any change in or any fluctuation in supply and demand in one region can impact the other region as well. This is not the case with the counterparts of power transformers called distribution transformers. They're small capacity, local producers. They're able to fulfill the demand for the utilities within every region. They have long lead times. We'll go into details of the lead times as well. So kind of having a local presence means a lot for the utilities as well. So what they do is sort of have a blanket agreement with an OEM once in the region, and they will stick with that. So they will continue to get that piece of equipment from that OEM for let's say 3 to 5 years. So those kind of blanket agreements are made once the utility makes sure that this OEM will be able to fulfill their needs for our grid. For example, in the US, this was a case because of some of the extreme climate conditions. A lot of grid was impacted, and there was a need for new transformers, new transmission lines, but the capacity for the local producers was at maximum, so they were there was a problem for the utilities. So what they had to do is sort of kind of get the equipment from the other utilities as well in the case of this emergency purpose. Before going into the details of European and North American market, I want to give you kind of an overview of global situation that through our research on global scale for power transformers, these are the major markets that we think that you should keep an eye on, because the utilities and the system operators in all these countries, they have at least 10 years planning for the grid infrastructure. That includes power transformers, definitely. So these are the markets that we expect to grow definitely in the future. Let's discuss, before going into the details of European market, the North American market. You see, it has crossed $3 billion US in the past. Over here, since we are now talking about a very specific equipment, you saw that we had kind of timelines ranging from 2019 till 2030 when we were talking about the overall grid infrastructure. But since now we are coming down from system level towards the equipment level, so based on our experience, forecasting beyond 5 years is kind of tricky. So we always restrict our forecast timeline whenever we are going from system level to the equipment level. So that is the reason. And I also wanted to give you some of the historical data as well, that to see kind of what has happened in the recent past and what is the trend in the future that is expected. You see kind of two different behaviors, right? One is steady growth that is happening right now, up until now, and then we see kind of sharp growth in the near future as well. Yeah, definitely we can segregate these two. One is right now, up until now, new substation additions. So new substations means new power transformers are required for the system. So that has happened up until now. But the specific thing about the US grid, since it comprises of the major part of the North American grid, that it is old. The transmission infrastructure in that grid is old. Usually, when we talk about transformers, transmission lines, circuit breakers, and other pieces of equipment, the overall timeline or the time for which these equipments are installed in a grid infrastructure is 30 to 40 years. And overall, in North American grid, or US grid, I should say, over 70% of the transmission equipment is either operating near the end of life or even beyond the end of life. So that is kind of a concern for the utilities, all the major utilities in the North American region, to sort of replace and revamp the grid infrastructure. Because in the recent past, some of these critical equipments, they have caused major breakdowns as well in the grid infrastructure. So they're really planning to replace these kind of critical pieces of equipment, and power transformer is definitely considered very critical piece of equipment, because one transformer failure can cascade the impact, and other transformers can also get impacted. So this is the kind of growth we expect in the near future in the North American grid. However, in the EU grid, we do see there is a growth right now that is happening. Why is the case? Is it once again replacements, or is it just new additions into the market? We saw that recently it crossed $1 billion US, only the power transformers market that we are talking about, and there's a steady growth that we are experiencing right now. What are the factors? Why is it happening right now? As opposed to the North, that's the prime reason I want to discuss the North American market, is because in European grid, new additions is the major reason for the market development. Especially some of the Central European countries, they saw kind of roughly around 6% annual increase in 2017. The reason why, once again, renewable additions. For every megawatt injected into the system, you need to have more capacity, more substation capacity, more transformer capacity, and more transmission lines capacity to be able to transfer from the generation centers towards the load centers. So that is why these new additions into the grid are definitely necessary for the grid operators. We saw two different trends. The market growth in the recent past, I would say from 2014 to 2016, was because of the price increase. Because it can be the ASP increasing or it can be the units increasing. Both these factors can influence the market. So between that timeline, so you saw there was a price increase, and that kind of caused the market to go up. However, right now what we're experiencing is because of the new additions, new units of transformers going into the system, and that is the prime reason for the market increase. Yeah, now we'll look at the market of Germany. This is kind of the similar pattern we saw at the overall EU's level. And this is the biggest market in EU 28, definitely for power transformers. And this fluctuation, once again, it is because of the transmission planning from the utilities. In some years, there's a plan to revamp one complete network, one complete area, and that kind of causes the market to go up suddenly. That is why you see these kind of fluctuations in the market. As I said, that we will also talk about the lead times. That why does it happen? So you can see I'm not going to go into details of all these steps, but you can see that the lead times, they are definitely high in terms of power transformers. Imagine a utility that needs to install a power transformers immediately, and they know that this is the lead time that they're dealing with. So having a local presence for an OEM is of extreme importance for utilities as well. And once they have this kind of relationship built with an OEM, they tend to go with that particular manufacturer for some years. This is an average, 9 to 12 months is an average time. However, in some cases, it can go even up until onto 19 months as well. So this is the average time that we're talking about. If we talk about the different categories within the lead times and what is happening at every step, we do not expect any sharp change in the lead times for the power transformers, because there can be different factors that can either increase or decrease the lead time. If there is a new local manufacturing facility being installed, that definitely decreases the lead time. Any technological advancement that impacts the market, that also changes the kind of the overall lead time as well. So we do not expect in the European region to have a very sharp shift in the lead times of the power transformers. However, in some of the Middle Eastern countries, since there are plans from the OEMs to install new manufacturing facilities in the Middle Eastern region, so over there we expect some change in the overall lead times of the power transformers. And now let's take a step back from this regional approach and talk about the overall global situation of supply and demand. What is happening from the OEM's perspective right now? If you talk about the tier 1 players, they are right now operating at roughly 75 to 80% of capacity utilization if we take into account all the manufacturing facilities globally that they have for power transformers. In some cases, they have manufacturing facilities for power and distribution transformers combined, but this is only taking into account the high capacity power transformers. Why there is a surplus capacity, why they're not at full capacity right now. We can basically break it down to some of the regional plans being made by some of the countries. For example, in India, there were some huge plans to add new generation capacities. They all got delayed, and OEMs, they were very eager to install new manufacturing capacities to sort of fulfill those plans. However, since all those plans didn't go through, so that is why we have this kind of gap between the supply and demand right now, or the capacity utilization. We expect this capacity, overcapacity, to go a bit up in the next 2 years because of the new manufacturing facilities that I just discussed in the previous slide. However, overall situation will change in the long term. So it looks right now that 70-30% is kind of the capacity difference in terms of idle and utilized capacity, but this will narrow down in the future since we'll have more, since as we saw that the requirement from the utilities is expected to go up in North American region as well as in European region, even though the influencing factors are different in both the markets. However, we do expect that since that kind of need from the utilities is going to reduce the gap between the idle and the utilized capacity. Yeah, overall, if we look at the situation, that's how it looks like. This is the kind of increase that I was talking about previously. Yeah, so you see in the first 2 years, there is a slight increase, but overall, the gap is going to narrow down. This can change in some regions if we go at the regional level. For example, as I talked about the North American grid, those extreme climate events, those impacts onto the grid, they definitely impacted the capacity utilization. And in those regions, the utilization for the local manufacturers, it definitely was ramped up to sort of be able to fulfill the needs of the utilities, those immediate needs from the utilities. But yeah, it all depends on those specific severe events that the grid experiences in some regions. But overall, based on the plannings from the transmission operators, based on the planning from the OEMs to have new manufacturing facilities, this is the situation from the supply and demand perspective. To kind of summarize overall presentation, what are the key takeaways? We did talk about North American grid. We talked about some of the equipment, transformers, HVDC as well. But from the grid's perspective, these are the key takeouts from my side. One is tier one players. I should actually say tier one European players. They're definitely dominant in this market. Some of the Asian players, they are trying to penetrate the market, but there are definitely some hurdles in that case. Definitely there are some grid codes which do not go completely in alignment with the equipment provided by some of the manufacturers, and the price difference as well. And then once again, the relationship that I talked about, the utilities and the OEMs relationship, since that relationship has been built over the years, that trust has been built, and there is a tendency in the system operators and the utilities to have that kind of a pattern where you want to go with the same manufacturer again and again, because you know the reliability of the equipment, you know that the O&M services will be provided from the manufacturer, so you tend to have that relationship built with the manufacturer for many years. As we discussed, Germany is expected to be the biggest market in, let's say, next 5 years because of all these plans that we discussed from the transmission system operators. We talked about the HVDC interconnected grids. European countries, they have been connecting their grids with each other through these HVDC, and we expect this to happen in the future as well. We talked about all these new HVDC projects being planned by utilities from different countries. Even within countries, for example, in Germany, we have some HVDC projects planned to connect sort of northern region where you have higher injection of the renewable energy, especially wind power, and you need to kind of connect it with the central load centers in the country. So you need to have these HVDC. So it can be within the country and outside as well. We did not talk about the digitalization of substation, but this is a key trend that we have been experiencing. This is, since it links with the other industry, not specifically with the transformer, it goes for every piece of equipment within the substations. This is what we have been experiencing in the recent past, that the utilities, now they're definitely moving towards digitalization of the substations. And the asset health monitoring, sort of gather the data from all the pieces of equipment from the substation and sort of make that decision making to avoid failures in the equipment. As we discussed, that these critical equipments, pieces of equipment, you need to have that kind of visibility in the future based on this data that you can gather. Right now, most of the utilities, they are definitely planning to have, if they're going for the new piece of equipment, they would definitely go for the equipment with these kind of systems inbuilt. And we see this from the OEMs as well. You have intelligent transformers being built where you have the capability to sort of gather all the data within the piece of equipment, and you can have those decision-making algorithms being developed on top of that can save definitely your equipment from failure, and that can predict the failure as well for the utilities.